and welcome to the BGSS webinar, the Atomic Design Lifecycle. This talk will be followed by an interactive panel Q&A, so please don't hesitate to post questions in the Q&A throughout. The Q&A can be found on the bottom panel. When pressing the Q&A button, it will open a pop-up on your screen and you'll be able to write your questions or comments in there. I will now hand over to Ollie, Elliot and Josh. Thank you so much, everyone.
Thank you, Fern. Hello, welcome everybody. We are going to start with a round of introductions first before we move on to the actual slides. So we'll start with me first. I am Josh. I'm a UI guy, a software engineer, a tech lead when I'm allowed to be. I've been with BGSS for 5 years now, next month, and I've spent a lot of my time working on front-end applications over a few projects. So I've worked on React projects, AGILE projects, been on a few Vue projects recently as well. I started looking into atomic design back in 2017. And over the years, I've seen a few varying interpretations of it. Over to Ollie.
Hi everyone, I'm Ollie. I've been at BGSS for a couple of years now. I'm currently a test lead. I strongly believe in tests being present at every stage of software delivery, which suits me very well because I'm very nosy and I like being involved all over the place. Elliot introduced me to atomic design about a year and a half ago, and I've really paid the favour by using my physics background to provide lots of metaphors and horrible puns throughout this presentation. On to Elliot.
Yeah, I'm Elliot. I've been with BGSS since 2015, and over the years had various roles on various projects, always in and around testing. In 7 years, I've learned a lot about the industry, a lot about myself, but mostly how amazing it is to feel like you're working as part of a team that fully support each other. It's through this teamwork that we're able to present today. The Atomic Design Lifecycle is one of my passions, but I'm super excited that this passion is one that's shared, and it's one that we're going to be talking to you about.
Excellent, right. So we are here today to show you our interpretation of atomic design, our history with it, and what we've done to iterate on it over the past 4 years. We've added an extra 30 minutes onto the end of the session, as Fern was mentioned, around Q&A. So we're going to have Elio Costa and Colin Cripps join us to field the design and analysis angle to any questions that might pop up throughout this. As Fern has mentioned, if there are any questions come up, just ping them into the Q&A feature and we'll go from there. We shall begin.
Cool. So I've got the wonderful job of teaching a little bit of history. So where do we start? Well, 1970 is the start of ATOHIC, but we're going to skip ahead to 2001, the year that Space Odyssey was set. But something much more important happened in reality, the conception of the Agile Manifesto. And it really has changed, or formalized at least, how we work together in teams, our ways of working. To those unfamiliar with the Agile Manifesto, there's many objectives and principles, but one outcome is that it should avoid some unnecessary silos, thereby reducing waste. And another is to constantly evolve practices. Jump forwards 20 years, and here we are. We're in an agile world that sometimes forgets the roots of the very foundations on which it was formed. Agile is a mindset, a spectrum, and no one team is agile or not, just on a pathway of agility. That Agile Manifesto has not been the only change. And as a result of these other improvements, our industry has changed in the past 20 years. And importantly, if we stay true to those processes and learnings, we have to recognize that the industry will keep evolving. Agile is not just a fashion, and very few people think that these days. Where once it was seen as a disruptor of the industry, it is now commonplace. And whilst we don't think that Atomic Design Lifecycle will necessarily do the same, or it would be a strong belief to share in public, we do want to recognize that it's worked for us, and we want to take the opportunity to share it wider. And fundamentally, it is just a demonstration of something that has come from working with agility. So in short, we've got some extensions to an existing process that really is proving valuable across our teams. But before we share the Atomic Design Lifecycle, we want to talk to you more about the journey of where this has all come from. And because if any of it sounds familiar to you, the Atomic Design Lifecycle might just be the accelerator that you need too. So in 2018, in a somewhat dated office block in Sheffield, I first collided paths with Josh. I'm not ashamed to say that in my career to that point, I really hadn't experienced a truly slick Scrum delivery. I entered the team and there were processes and collaboration and camaraderie, but all of those positives were seemingly worthless. Our tests sucked. Now, I feel I can say that with hindsight, and I want to clarify by saying they did work, They weren't flaky. There were a lot of tests that protected the delivery, and the whole team had testing baked into the delivery patterns. So it really wasn't bad, but for other clients, I have seen worse. However, there were some very common anti-patterns on full display. And once again, I am only able to say that with hindsight. So we all sat next to each other. We had daily stand-ups. We all moved post-its about on the board, but devs did, well, development. And you probably guessed that testers did testing. There was very little overlap between the two practices. I'd even go as far as saying that there were some trust issues as an outcome of that separation. The tests had worked to pick up a lot of issues, but it was following a strategy aiming for extensive coverage of every UI field. Each had multiple tests, and probably for almost all behaviors, and they were written against them in a way that also was covered in the UI tests. In terms of a test pyramid, that middle layer was starting to look the widest, and the unit tests were covering the same stuff as the component tests, which was really weird. And whilst we're talking about those behaviors, I was getting more review comments on my BDD rather than on my code. We were almost entirely scripting a solution sprint to sprint rather than an engineering one that would stand the test of time. That same BDD was almost exclusively used by technical members of the team. Even though we were following many industry standards, it felt like the bit that joined them all together had been missed or was being overlooked. A great example of this was following the page object model pattern. Again, this happened, but pages were in some cases over 1,000 lines long. All in all, we were doing everything that we thought we should have been, but in our own little siloed worlds. We were really overlooking some of the improvements that we could get from working in a much more agile manner. Nobody could question our dedication and efforts, but something was going to have to change. We really were going to have to rediscover some agility. We were working hard, but not smart. By late 2018, the mess had grown. The effort to maintain the test code was starting to far outweigh the efforts of adding the development code. And these were not just one-off cases. This was really getting bad. As the deliveries got more and more risky and more sprints started to fail, we realized that all of the flexibility of the development code had not been applied to the test code. Uncle Bob warns of this in the book Clean Code, but what we saw was we'd allowed the test code to be treated differently to the dev code. A lot of the code could have been written, but a significant chunk was repeated, and the same cynic amongst you would probably think that it had been copy-pasted. This was partly down to business practices, partly my own ability, and also what happens when devs and testers are siloed like that. The sharing just doesn't happen, and engineering improvements don't happen in parallel. New practices and principles aren't shared, and the gulf between practices only grows. One major change that caused these problems, though, was the introduction of a new region. But just like most businesses, this was not just a small language change. Processes, user flows, even data, they were all going to be different. We had to make a lot of changes quite quickly to test the code. A lot of the work was done to optimize those objects from being 1,000-line files, and parallelization was improved. Unsurprisingly, the parallelization was needed because we were having hundreds of tests, and it really was pushing the phrase fast feedback. Worst of all, in my opinion, though, was the nature of those failed tests. If something broke on that first page, every test for every subsequent page was going to fail because it couldn't get past that first page, but only after a generous 10-second timeout. If we were really going to fix this, it wasn't going to be to stop all failures, because that's not possible, but it was going to be handling them, and we were going to have to be smarter. We were going to have to start engineering. I don't think we actually ever got to breaking point, and I really don't think we were close to it either. But having been enabled to improve the code, had brought a few of us closer together, and we started talking. Yes, there may have been pubs and beers and a lack of social distancing at that time, but we really formed a relationship founded on quality delivery and shared frustration. So in early 2019, we had an opportunity to start working smarter rather than harder. With a clean slate for a new project. And those lessons that we'd learned by communicating only blossomed. Josh was different as a cell lead. For the first time in my career, we actually talked about how we could be better engineered, how we could better engineer the tests. Josh was engaged and cared just as much about the development code as he did about the test code. We also were given another secret weapon in the form of our new TA to the project, the final catalyst to this change, Ricky Bearfield. The scene was set, the pain of poor quality test code had been shared amongst the entire team. The abilities of the engineers in object orientation had improved, and the team were working much closer together as part of a Scrum delivery. And as it all turned out, one of the key changes had been in front of us all along. Josh, along with the UI development team, and I'm sure many other businesses, had been using an atomic approach to delivery throughout the development repositories. Ricky looked at some of my improved code from the previous project and asked a simple question. Have you heard of atomic design? That was the pivotal moment for us. The penny dropped. Our origin, our year dot, our eureka moment, our big bang. But we hadn't invented anything. We just embraced some agility by having some interactions. And by colliding this theory with testing processes, it resulted in the discovery of something new. And that might have just been new to us. But in an instant, it felt like we went from nothing to something big. And since that point, it's felt like there's no turning back. There's been a chain reaction of events that have led us to where we are today, in front of you. Internally at BJSS, this meant some blog writing and shouting as loud as possible about the benefits of applying atomic design to our test methods. And on the project, only a few weeks later, our systems had formed and the development of test practices were aligned to using atomic design. But what is atomic design?
So what is atomic design? In its simplest format, it's just a design pattern. It's a nice way of conceptualizing a project's components. It does apply to development code, but it doesn't just apply to development code. There is a way of thinking that we can apply this to design systems, analysis, story refinements and breakdown, UI code as well, component libraries and test automation code. To break it down as a theory, we've got to start at the lowest level we can do, which is the atom. There's basic groundwork components for your entire application, and these are the ones that should be used the most. For example, buttons, labels, headers, inputs, dividers, icons, etc. The list goes on. In a design system, you'd be building these ahead of time as components or symbols, and you'd make a larger component and page around them. Next, we have the molecules and organisms. I'd group these together personally, as the lines can get a little bit blurred. But simply put, molecules are usually a collection of 2, 3, or 4 atoms that are commonly used together and could be made common. Organisms, I prefer to look at as an established section of the page. These are the main building blocks for your application. And the relationship should be that organisms can be made of molecules and atoms, and molecules can be made of atoms, but you shouldn't be using organisms and molecules, and you certainly shouldn't be using them in atoms, as that breaks the pattern. Exceptions can be made where required. And the final 2 layers, so the templates and the pages. So templates are where you draw together the main scaffold of your application and how components sit together structurally on a web page. This is the highest structural styling that should be applied in the UI code. And pages are where you map your integration points, your state and your data into your components. To summarize, templates are style and structure, and pages are data, state, and integration. Now, I know that was a lot of words, way more than you might expect for such a simple diagram. So it's probably best to give you a bit of a worked example of something you should be familiar with. This is the sign-up form that you will have all used to sign up for this event. Before I start, I'm going to add a disclaimer here that, like many things in software engineering, a lot of what you'll see is completely subjective. What matters is that the team who build these elements agree to the right level for each component. So we're going to start with the lowest elements again, the atoms. Elements such as labels, inputs, buttons, in this case, these are the elements that you want to make into components right at the beginning. The aim is to componentize anything that you consider to be a core part of the application. And these elements will be very simple from a markup perspective. But if you're considering accessibility, which absolutely every project should be, you've also got to concentrate on the ARIA tags here as well. Any modern front-end library or framework will allow you to expose props, and that's something that you can use to pass the relevant information through to the components when you're using them. To come back to my subjective disclaimer a few moments ago, we're going to have a few molecules in here. The first is the form description, which absolutely could be argued that it's an atom because it's just a single element, but actually there's a link in there as well. So it's not just a simple thing anymore, and it's going to have one, potentially multiple components inside of it. And the second molecule is the form import, which can be seen as it's common usage of two elements there, which is your label and your import. Now, you could leave the use of these two elements down to the consumer of the components, but if you're going to do that, if you're going to use them a lot, then you may as well just group them together and expose props to pass through to them. The final bit to highlight here is that these are components in isolation, and they shouldn't do anything in isolation. A prime example would be the register button. As a standalone component, you just have a button. When you click on it, it exposes an event. It triggers an event that the user of that component will do something with. If you want this button to be completely reusable, it wouldn't make sense to plug event handling directly into it. Otherwise, you're going to have to recreate a new component, a new button component every time you want to create a new button on your page, which defeats the point a little bit here. At this point, we can start to pull it all together with form, which is obviously going to be an organism in this case. As an organism, you can either make this a generic component, or you can leave it to the template to decide what goes in that form. As an organism, it's quite easy to start losing reusability. So going back to subjectiveness, there's not always a right answer for which route you should take. Ultimately, you do whatever works for the team. Whatever the team decide is obviously the approach that you should take. If you've got multiple teams, then you need to decide between a few of those individuals and those teams. And in the case here, we're going to have a form that's composed of a form description, a form input, which is obviously going to have some sort of looping enabled on it to go over all those multiple elements, and a button there. Next up is templates. So referring back to my description summary earlier, these are for the style and the structure of the web page, scaffold for the entire page. They'll use templates to pass data and events to and from the page and the components. It's a bit of a middleman component, if anything, but there should be absolutely no logic in here whatsoever. It is purely there to style, structure the application, and to handle the data between the page and the components. And finally, we have our pages. So mentioned it already, pages is where you map all your data, you state your integration through to templates, organisms, molecules, and atoms. To keep it simple, without a page, just a template, you shouldn't be able to do anything with it. It's just a form that you can just play around with on the screen. But the minute you add that page into it, you can start sending that information somewhere as you map the data integration through. So to summarize what I've gone over the past 5 slides, what we end up with is quite a few components, but we have components that actually have single responsibilities. There should be absolutely zero blurred lines here. You should know exactly what to expect when you're maintaining any of these components. Form page, state data integrations, form template, web page, scaffold, structure and styling. Everything else under the page and template should be purely presentational. So Elliot ran through a brief history earlier and got to the point about finding out about atomic design. What actually happened next from that point? From a development perspective, we already had a bunch of components broken down into atomic components, but what we didn't have was tests following the same paradigm. By following similar patterns and making components and tests that married up with the development components, we're able to start reusing test classes that represented the atomic components. Now, code reuse is obviously great from a development perspective, and doing so in tests also helps improve our testability and the speed that we can get through delivery. Our current project was coming to a close with the client, but we were given something new, a 3-month opportunity to work on something greenfield, which allowed us to start testing this process out from the fresh. I should point out that we were a well-oiled team at this point. We understood one another quite well, but I believe that what we did does translate well to other teams. So what did we actually do? We began to start introducing whiteboard sessions into planning. Each story that had a front-end change on it was detailed on the whiteboard, and we confirmed the flows against the acceptance criteria for that story. Each story session was led by a member of the team, regardless of their role. By doing this in front of the whole team, we were able to start comparing our understanding with the analysts in the team, along with crowdsourcing any implementation ideas on the way. Any notes were captured as part of this, and we snapped a picture and attached it to the story as part of open and mass sprints. Now, the downside to this session was how much time it added on to the planning session. You couldn't just get a story, run it through from analysis and get your dev and test to go on their merry way. There were some days where planning would take half a day to a full day. But what we got out of that was a deeper shared understanding of what the goal was between dev and test. And the real benefit by doing this turned out to be what happened after those sessions. Now, Instead of the developer and the tester going their separate ways after that session, we now had a common starting point between the two groups, enabling them to set off from exactly the same position. Like I mentioned previously, completely well-oiled team, we did start thriving in this scenario. And I think it can be lifted to every team, but it may not be suitable for team members in every team. So you would need strong buy-ins. At this point in time, there's no guarantee. At this point in time that we was on this project, there was no guarantee that it would scale across multiple teams. And another point to make is around comfort zones. It's quite scary to get up for the first time and try to run through one of these in front of the entire team. But by getting people out of their comfort zones, we found that over time we started to improve individually and as a team altogether. So 1 year later, that project ran out for 6 months. It came to an end for us. As part of that project ending, the team was disbanded and we all went on our separate ways. And then a few months later after that, COVID happened. So we, 1 year later, ended up in a situation where we were all starting to work together now. And that is myself, Elliot and Ollie. It seemed like a good opportunity to start bringing this atomic process back into more projects at BGSS. With already a solid understanding of the process, but an inability to get together and do our normal planning process, we started to look to ways to evolve. So of course, it would be easy to try and lift and shift exactly what we was doing on the past project team, but we didn't have the same team members, we didn't have the same dynamic, and we also didn't have the same skill sets. So from an automation test perspective, we started to make common abstractions of components you'd expect to see on every web application and bundled that into a library which can be used across projects. Process-wise, like I mentioned, we can't do our planning sessions anymore. Everything's remote. We certainly couldn't do it with Zoom fatigue setting in over time. So that's when we started to bring in a dedicated sprint task. Ollie's going to cover this very shortly. And also, finally, at some point, we've scaled from 1 team to 2 teams to 3 teams. And this scaling has exposed some pain points around understanding and approach. But it's an area which we can tackle now that we're seeing it exposed, and it's a place that we can start to adapt again.
So this is the Agile software delivery lifecycle. I'm not going to spend too much time going through it since this talk assumes at least a little familiarity with Agile delivery, but I will give a quick overview. So in an iteration of Agile software development, we get requirements from the business. There is a design phase, both from a technical and user experience point of view. The teams develop these designs, the teams test the implementation of these designs. That creates a product which is deployed, and then feedback is received and reviewed, and we begin another iteration. And Agile is excellent, it can be wonderful, but there are a couple of common issues at a low level that we see. And these aren't issues with Agile as an ideal itself, but more issues faced on the journey to get there. And I want to emphasize that these are issues at a lower level, since we won't be talking about the enterprise level Agile scaling issues. So issue number 1, we see a lot of this. Despite moving to an Agile way of working, interfaces still present the most likely cause for conflict. This can be due to an ongoing transition from waterfall, a lack of direction on Agile expectations, or simply down to the way that people view their roles, which is something we'll talk about a little bit later on. If these interfaces don't have frequent feedback and interaction with each other, there will be friction and silos will form. In the worst cases, this can lead to antagonistic relationships. For example, limited interaction between development and test can lead to test having the mindset that it is their job to break what development gives them, and development will start to view test as a roadblock. DevOps obviously aims to break some of these silos, and it can be fantastic, but often implementation of DevOps focuses solely on the development and deployment interface. The other big issue with Agile is that without a consistent, conscious effort to foster the correct environment, Agile practices will fall away. I'm sure many of you are familiar with the term Wagile or Scrumfall. Wrapping Agile ceremonies in an inherently waterfall environment will not achieve the desired results. There's also the expression zombie Scrum used to characterize following Scrum ceremonies without the values or energy behind them, leading to no continuous improvement. Now, we want to avoid that, but it can be difficult, particularly if the interfaces that exist have different working environments. So what can we do to smooth over interface friction and provide a path around obstacles to agility? Well, this is our attempt, implementing atomic design across the Agile software delivery lifecycle. We've spoken about bringing test and development closer together, and we will continue to talk about that, but it's only part of the bigger picture. And what does this bigger picture look like? Well, it may just look like I've put a picture of an atom on top of the last diagram, but I assure you there's a little bit more to it than that. There are 2 main ideas that we're presenting here. We want something unifying that can be shared across the process and give an underlying structure to the life cycle. And we want meaningful interactions across interfaces to reduce the aforementioned conflicts. Let's begin with what we're going to use to unify everyone across this process. Things like team charters and shared values are really important and worth doing, but we're going to talk about something a little more tangible and practical that can be shared through a life cycle that may consist of several teams and that will have a direct use day to day. If we implement atomic design across our stories from their conception, suddenly design, analysis, development, and test are all working together with a shared idea of what our atoms, molecules, and organisms are. This shared idea becomes a shared language, which allows the sharing of further ideas to be much smoother. For example, a business change comes in, and that change is going to affect a certain organism. If you imagine a tweet on Twitter, starting a conversation with that shared understanding allows everyone to have a clear starting point. Using this language across both development and test code also allows software engineers to identify exactly where in the code they need to worry about. This shared language has then become shared objects in code and shared artifacts, which we'll talk about very briefly. So yeah, just the point that test and development, building their components from the same specification, further solidifies this shared understanding. And if you haven't twigged yet, the blue and red quarks represent this shared language, which is naturally at the core of the atom and at the core of our life cycle. So if that's the case, what are those black lines around the life cycle, those electrons? What are they actually representing? Well, a key benefit of introducing atomic design is what it brings in human interaction across the life cycle. Having a shared language builds a community, and it creates more natural feedback loops. Suddenly, two ends of a process that may not regularly communicate, such as test and design, have a common foundation. And if teams start to feel this joint ownership of a product, which shared language helps bring, a team pride emerges alongside that common understanding. So this is what the electrons represent, the interactions across the life cycle, which can break down interface conflict. So the shared language and interactions across a project are great, but for projects starting out with atomic design, what can we do to ensure that these things actually take place? Well, in our most recent iteration of the atomic design lifecycle, we had one team in particular that took to it like a duck to water. However, we found other teams were not adapting as quickly. So we looked into why this might be. What we found was an informal process that had been introduced as part of the ticket refinement and 3 Amigos sessions. In a similar manner to the previously mentioned whiteboarding, the team would break down the new components into their atomic structure. They would agree naming conventions and agree the IDs that these atomic components would have. And soon this process was formalized, with documentation becoming the artifact produced. I'll talk a bit more later about the value of processes versus interaction, but the interactions that this process forced helped to iron out a lot of the kinks in the atomic process. And it was the agreed documentation that really became crucial, since when work began on the ticket, there was that common starting point that we've mentioned. Naturally, this starting point can change as agile teams. We respond to change, but due to the communication up to that point, it tended not to happen. And just as whiteboarding provided that common starting point, as we said, that upfront documentation of the IDs gave test a real head start, since it allowed test automation to begin at the same time as development work. And not only this, but with proper alignment and communication, test automation can be completed independently of development code. As long as there is communication, whoever finishes last can be the one to turn the tests on. There are added benefits to this documentation too. After a while, it essentially becomes a Bible for the shared language across the project. The documentation is the artifact to produce, but the interactions and shared knowledge that take place as part of that meeting are the soft benefits that really help drive a way of working forward. We've briefly mentioned the effects of remote working. I think it's worth mentioning that whilst we've all, across the globe had to force interaction a little more due to missing out on the benefits of co-located teams, this process in particular really helped to bring our teams together, and it ironed out a lot of the small, seemingly minor questions that would normally be asked informally in a non-remote world. However, as great as this process is, there are bigger changes required in order to reap the greatest benefit from implementing atomic design through a life cycle. One of the tenets that surfaced in the early days of using atomic design across development and test, as Elliot has alluded to, is that good code is clean code no matter where it is. Therefore, test code should be held to the same standards as development code. This sadly isn't an industry standard, but it was something that we agreed upon very early in our implementation. We wanted to move all of our code away from scripting quick fixes towards engineering long-term solutions. And to be honest, this isn't just for code. In all of our work, we should look at the bigger picture and strive for sustainable, maintainable quality. So when it comes to test code, how exactly do we do this? Well, hopefully you recognize this from earlier. It's a breakdown of our talk submission form in an atomic manner. On the left, we have the key, and then we have the development code broken down in an atomic manner. And on the right, the test code represented using the page object model. We've spoken about this page object model already, but just as a reminder, this is having a class to represent every page on your user journey with methods contained in the classes to interact with the said page. However, there are most likely pages and components throughout your application that are repeated, and if there aren't, there may be bigger questions than the state of your test code. If one of these components changes and it is repeated throughout, that means making a change in every place where that component appeared in both your development and test code. If you're following the page object model, you're going to end up with a headache. And just following the page object model blindly can lead to many painful hours spent refactoring this unmaintainable code, and it furthers that development and test divide. So the obvious answer here is to introduce object-oriented programming. But that's only the first step. Let's take a look at what Atomic can do to drastically improve the state of your test code. Our solution is to move from the page object model to the atomic test object model. You can see that we've broken the test code down in the exact same atomic way. Why might we do this? Well, if we apply the atomic model to our test code, we get a number of benefits, but let's focus on the clean code aspect first. Breaking up our test code into reusable components has all of the clean code benefits associated with object-oriented programming. It allows a single source of truth for each atomic component that we have, and it helps us break away easily from the page object model. Cleaner, more maintainable code means cleaner, more maintainable tests. This means our tests are easier to read, easier to understand, and more able to respond to change. This helps us prevent the issue early on that mature projects that haven't invested in strong test automation code can face, where the question often becomes, which test can we turn off due to a massive test pack delivering minimal value per second of build time. Nightly builds aren't necessarily something to strive for. And naturally, the effects that this can have on a modern project aiming for CI/CD are huge. There is another part to this though. You may have noticed that our development code on the left and our test code on the right are mapped to each other one-to-one. This is a natural consequence of that shared language and atomic breakdown process we've spoken about. It is worth calling out that this would probably work best with a shared programming language between development and test, but it's definitely not necessary. All the benefits of a shared language are amplified when dev and test code very closely resemble each other. Maintainability is implicit, and we find that refactoring responding to change becomes a breeze rather than a storm to be endured. A final extension of this is the use of a component library. Now, component libraries work exceptionally well with atomic design, as Josh has mentioned earlier. However, that tends to only include development components. There's no reason that we can't build test components alongside this for consumption by the test frameworks that sit alongside your development code, meaning that the component library suddenly provides an atomic structure throughout your entire project. And to just end on a less implementation-focused note, it isn't just the idea of object-oriented programming and clean code here, but planning and testing and treating test code in the same way that we treat development code. Doing this, by the time that we write code, the entire team have a very clear picture of what needs to be done. So, engineering alignment doesn't just end with having high quality test code that is mapped to development code. We want our teams to have understanding across the entire process. And I believe the biggest gain that can be made on the dissolution of an interface is between development and test. To call back to earlier example of a muffin top test pyramid, if developers and testers don't have a clear understanding of what each other are doing, at least two bad things are going to happen. Firstly, there's definitely going to be duplication of effort. And secondly, issues will be missed at some point due to knowledge gaps that the other discipline could have filled. Moving from a team of developers and testers to a team of cross-functional software engineers is a transition required to best avoid this, in our opinion. Developers that learn to test become better developers, and testers that learn to develop become better testers. Cross-functional teams aren't just teams of mixed specialists. They're teams that have knowledge transfer on a day-to-day basis. And this builds multi-talented teams that easily avoid single-person dependencies. Specialisms are great, but silos most definitely are not. So aligning development and test standards does have great benefits, like the shared language and the clean, maintainable code, but is also the biggest factor in achieving this transition. If testers understand exactly what unit tests are doing, and developers understand the automated test at a higher level, they're able to minimize duplication and ensure appropriate testing takes place at the right level. Not only that, if your test code is good and exciting, your developers will want to take part, making it better, and your testers will get more competent technically, meaning they're better able to understand the system under test and can dive into the development code themselves. These high standards and the dissolution of this divide have enabled us to do some powerful things in our most recent test framework iteration, such as the implicit assertion of elements throughout a journey, reading the development config to direct test, for example, the ordering of our atomic components, reading development copy text files and implicitly checking that the correct text appears, integrating with user analytics, and having automated accessibility checks throughout our user journeys. Now, you may be wondering what relevance the image on the slide has here. If you've really been paying attention, or you're rather nerdy, you'll recognize it as representing the shift from the planetary atomic model to the quantum atomic model that Josh showed us briefly earlier on one of his slides. For anyone who needs a physics refresher, the main idea of this shift is that electrons used to be thought of as bits of matter existing in a certain place and state. The quantum model changes that idea, and instead, electrons exist as probabilities of being in certain places and states. To end on another metaphor then, our aim is to move to teams of quantum engineers. Someone who was a developer still has a good probability of working on development code, but as a quantum software engineer, they could well be writing test code or even getting stuck in with analysis and design. We see this as the next natural evolution of agile theory, and hopefully it's a lot easier to get your head around than actual quantum mechanics. So, we've spoken a fair bit about the theory and what we think is necessary to successfully implement an atomic design lifecycle. However, a few learnings in particular stood out to us as worth calling out. The first of these is the relationship between processes and interactions. We've emphasized interactions a lot so far, and if you know the Agile Manifesto off by heart, like I'm sure you do, you'll know that the first value is that individuals and interactions are more important than processes and tools. We've got several processes that we love, such as the atomic breakdown, but why is it exactly that we love them? Now, I believe that the core reason behind any formal process we have is to drive interactions in a positive way. Efficiency and documentation are other benefits, but if we lean too heavily on these and forget to prioritize interactions, our processes will become dull and lifeless. If we don't bear in mind that processes are there to drive interactions, agile ceremonies and things like the atomic breakdown just become stagnant tick box exercises. Now, processes rising organically is excellent, especially if the team is empowered to make those changes to their way of working. But as we mentioned with the atomic breakdown, scaling these processes can present issues if we don't keep this core agile value in mind. The what and the how are important, but they'll fall apart without the why. So, to refer back to our atomic design lifecycle metaphor, we can see that our processes, tools, and artifacts produced along our lifecycle are the solid red and blue matter in the middle here, clumped together. These are visible evidence of the atomic design lifecycle. However, the vital unseen electrons representing the interactions that we have across using these processes are not as visible, but it's the communication and engagement in these things that drive change. They're what bring real energy to a project, and ultimately, for anyone that remembers their GCSE chemistry, these are what create bonds. Now, these bonds are important, for they enable us to defeat a consequence of the interface conflicts that we spoke about earlier. So, we've spoken about how our quantum software engineers can do more than just their job title and the benefits of having cross-functional teams. Silos are the natural conclusion to interface conflict, and that specialisms provide value, but silos themselves are an agile killer. We've spoken about processes that can help to eradicate these, and we've emphasized the power of interactions to do this. However, there is a hidden factor that if you don't look to mitigate, it will severely impact your ability to remove silos. And this factor is the self-siloer. It's one thing for someone to be stuck in their ways and not want to interact outside their silo, but we found generally if someone has that attitude, agile isn't for them, and there have probably already been issues. The self-siloers that we refer to are people that lack the confidence to take that next step, whether it's a tester lacking technical confidence to look at development code, or an analyst that feels unable to participate in technical discussion. There will be people who agree with the ideas here in principle, but don't feel like they're able to make that step. And this is where our trusty interactions come in. The bonds that we've built across our development lifecycle, they build trust and psychological safety, and this breeds an environment for confidence to grow. From there, we can build true communities of practice where people with a range of experience and skill are still able to contribute and discuss ideas. We hope that by changing hearts and minds and giving support to those who need it, you can decommission your silos. And whilst teams can do this well themselves, there is one factor in particular that will determine whether you'll make that step at speed. So, teams can adopt ways of working, such as atomic design, and find success with them. However, if there is not commitment at a higher level, there will be constraints around that success. Leadership needs to be fully committed to this and understand what comes with it. To build cross-functional teams and benefit from the value that they bring, a strong support network is required, whether it is building that psychological safety we've mentioned at a high level, establishing a vision in which everyone can participate, or protecting your teams from outside interferences that could threaten the success of these new ways of working. Delivery management has a huge role to play. And if delivery still treats teams like they exist in silos, there will be an internal conflict that halts the progression of that cross-functional team and limits their ability to succeed. Technical leadership naturally plays a very big part too. Technical leadership really needs to be the first to unsilo themselves. They can't leave design, analysis, or test to their own devices. Particularly when it comes to test code though, it's really important that tech leadership aren't just passengers, but they're drivers in quality there. Leadership sets the tone, so if you are technical leadership, lead by example, get stuck into areas that you're not a specialist in. You may find that the definition of leadership changes here. It doesn't always mean providing experienced opinions and direction. In these new areas, facilitating knowledge transfer and building a culture of curiosity and collaboration will be far more valuable.
So there are an absolute load of advantages that we've found following the atomic design lifecycle. It's definitely not a one size fits all, but it does stress the importance of embracing agile ways of working. Presenting here today will hopefully represent just the beginning of the path. Some of you may head away and do more learning and collaboration from this, others may not. But as long as we've clearly represented what it means to us, then for us it's a job well done. However, for us, there are some aspects that we absolutely do want to build upon in the next phase of our journey. As we've said before, atomic design lifecycle is just a catalyst. It absolutely could be extended to other disciplines and extended to stakeholders and aid getting fast feedback from customers. There is no reason that this process would be restricted to just an engineering pool. However, we currently haven't added any formalizations around this, and hooking into tooling like Storybook could be a really nice way of bridging that gap. The other thought is that what Gherkin has done for formalizing BDD, the atomic design lifecycle might do for UI research, design, development, and test processes. It absolutely represents that common shared language between multiple disciplines. Using images, whether these are informal sketches or dynamic demos, really help us all get a better understanding of what we're trying to deliver, but also what could go wrong. As they say, a picture paints 1,000 words, and in this scenario, we can really shorten the feedback loop. Much like BDD and Gherkin, it can be absolutely a common language shared over multiple disciplines. Silos exist in a lot of industries, and as Ollie has said, specialists are not a problem, provided that they are still generalists. One of the hardest things that we think is important to all of this being a success is breaking down those barriers. We want dev and test and all other disciplines to start being much more theoretical and less about which camp we sit in. We'd also like to talk about this subject more. This presentation itself represents the start of this. More sharing within BJSS and outside of BJSS too. We believe in our pattern and at minimum want to make that pattern present for others to iterate upon. And a long-term aim would probably to create and externalize some of those libraries that we're talking about to help with that engagement. Creating something open source would be something that we'd love to do to give back to the wider community. Most importantly of all though, we want to remain compatible with the Agile Manifesto. In adhering to its values, we can't overlook that what we've presented to you is a process or a tool, but we never want Atomic to be just that. We want it to represent the positive interactions between the members of a team. So, is there a message here? In truth, there are lots. Agility might capture the headlines, but there are more than a few subtle themes here that flow through what we've covered today. In terms of balance, dev and test code should be treated with the same quality, care, and attention. And it's not just the code, it's the people too. And in terms of change has been really good for us. Striving for better and the best for our clients has allowed some of these iterations to cause some improvements. So If you spot something like this, don't assume it's been thought about already. Probe into it and try and continually improve what you have. We have the proof. Atomic design had been around for years before that Big Bang moment. And that headline of agility, don't ever forget to embrace it. Right, so we're into the Q&A part of the show. Hopefully you've been spamming the Q&A with loads of space and physics related questions for Ollie to answer rather than the atomic ones for us to answer. But before we get onto those, just introduce the two new members of the panel for the Q&A section in Elio and Colin.
Hey everyone. Yeah, my name is Elio. I'm a product designer at Spark, which is the design arm of BGSS.
Hi. Yeah, I'll go next. Yeah, my name's Colin. I'm a business analyst at BGSS. Been there about 4 years. I worked on a whole host of different projects. Got introduced to the atomic design lifecycle by these three earlier on this year, probably about 6 months ago, something like that. So quite new to it, but enjoying the journey so far.
Welcome, guys. Right, so we have got, I wasn't sure if Finn was going to do this, but I'm going to step in and do it anyway. We've got a question from Luke Smith. I'm just going to read this full thing out, Luke, so I apologise if I do you injustice right now. So, as you know, I've worked with a atomic design and a test framework, and whilst I'm a massive proponent of applying proper engineering principles to test code, I found atomic design had a tendency to lead me towards abstractions, potentially over abstractions, both in code and conceptually. That actually took me and my thinking further away from the end user and user experience. How do you make sure that's mitigated?
It's a fantastic question.
Yeah, just to write it down and take it in.
I think part of this is, so I know when you worked on it personally, Luke, it was sort of a learning curve for all of us in picking up atomic design and getting used to it. And I think it's the same when anyone picks up the classic question as soon as someone starts working with this is, well, what's a molecule and what's an organism and where's that line? And I think that doesn't help with the abstraction stuff. So I think that's partly is just getting used to it helps us to get away from this. And I think one of the other points is why those interactions are so crucial. Because if test exists by itself and it is just sort of head down in the code and doesn't get to have these conversations with, you know, user feedback or design or analysis, then that will happen and it will take you away. And then I guess just a final point as well is some of this will I think just come out in the wash. Exploratory testing is still going to take place as part of this life cycle, and I think that is what brings you back to reality in actually interacting with the application and thinking from a user's point of view.
Anything to add to that, Elliot?
Yeah, I was going to add on about the over abstraction as well, because obviously it's really difficult to draw a line even on that, not just talking at the atom, molecule and organism level, but even at a conceptual level. I think it's not necessarily something that you need to think about, Luke. It's more of a team decision, and I would rely on those around in your team to help make that decision. Not that I'd be questioning your decision making, moreover that actually I think that those interactions that we're talking about, I think it's nice that someone would be able to turn around and say, hang on here, you are massively over abstracting that. Do you really need that? And there is that Yagni principle of you ain't going to need it. I don't think we'd ever advise to just blindly follow this if Yagni was going to be quite obvious. Yeah, it's obviously evolved quite a lot, but I think it's all in those interactions and making sure it's a team decision rather than left to the individual, to be honest.
Cool. Cool, excellent. Right, I'm going to jump on to the next question now. We've got one from Abby here, which is, do you think there are any situations where waterfall is more appropriate than agile? So I'm not going to answer that myself. I'm going to hand it over to Ollie or Colin, possibly, to put their say on it. What do you think, guys?
Yeah, Ollie, I'll jump in there. I certainly do think agile and waterfall both have their places. You know, there are sometimes situations where things and variables aren't changing much, and a lot is known. You might have a very restrictive kind of course on requirements. Maybe there's some very strict deadlines based on regulatory things. And maybe it makes a lot more sense to use a waterfall approach to that. I guess my counter on it would be agile is quite a spectrum. It doesn't have to be applied in one strict core frameworky sense. And you can flex and take that right away across that spectrum to be a super CI/CD based agile thing where you're deploying all the time. Everything has value, right down to just we're reducing risk by doing things iteratively, you know, adding value as and when we can. So you can flex that spectrum closer to waterfall or more to a purist agile approach. But they do each have their benefits, I think.
Yeah, spot on. I guess just the only thing to add on that is that obviously we've not tried atomic design in a strictly waterfall approach. We could give it a go, and maybe that's one for us to have a think about going forward. I still
considered.
Yeah, I think there would still be benefits. That shared language could absolutely still apply, but yeah, one for us to think about maybe.
Equally on that spectrum of agile, you know, with if you put waterfall at one end, Scrum somewhere in the middle, and Kanban on the other end, we haven't done it in Kanban either. So we've been very much focused from a Scrum delivery perspective. But yeah, I agree with the rest of the panel. Unfortunately or fortunately, that yeah, I see no reason why atomic design wouldn't work using any methodology. I think the advantages would just be different, whether dependent on which flavor you're tending towards.
Going to move on to the next one now then. So we have got one from Omri here. Front-end frameworks, especially React, seem to be embracing the functional programming style more, and building things from small blocks seems a very functional programming way. Is there any concepts from the panelists as to why test frameworks continue to be mainly object orientation?
I'm going to be very biased here and say that honestly, I think it's down to sometimes the ability or the people that we have that, you know, talking about that dev test divide that we've talked about. I don't think that's just something that we have in a few companies. I think it's throughout the industry. And I'd like this kind of discussion to start to change that across the industry. That is probably something that's quite close to my heart, to be honest, to stop that happening, because I think an outcome of that separation is what causes, you know, the way that some test approaches are often written to feel like they are quite behind some of the advantages. So, you know, exactly what you've said about the FP way versus something being OO, it comes down to those interactions. If those don't happen, and we don't start to educate different groups of people on different methodologies, that split will just start to happen again, and you'll end up with different methodologies on one half of a silo, and the other half of the silo doing what perhaps is a bit more familiar. Hopefully that didn't come across too opinionated though.
I don't think it did. No, I think correct. I've actually been on a React project that did look a little bit like an object-oriented car crash, if anything, which from a JavaScript perspective, a modern JavaScript perspective, it wasn't ideal for people who are front-end developers going into that, because it's not really the paradigm they're used to, not all the time anyway. I suppose it really does just depend on the team and what the team are wanting to push forward with. It wouldn't make sense for one, you know, the UI to go a certain way and the automation to go another way. But I think from a component perspective, we don't have to worry too much about that, or at least I've not seen too much reason to worry about that, because a lot of what you're using doesn't feel like a functional program way of doing it. I know it is kind of going that way, but it doesn't feel like that kind of way. Have you got anything to add to that, Ollie, at all?
Only thing really is I think it's a really good question that I've not heard before, and I think there probably needs to be from our test capability lead right here, Elliot, something further on this to talk about.
Yeah,
you volunteered me for something there, Ollie. Thank you.
You're welcome. Yeah, paying you back.
You've got some work to do tonight. Right. Next up, we got Greg. Welcome, Greg. And as well as developers working on test and vice versa, there's also a big push to get developers running the platform side of things too. So how do you avoid the burden of people ending up doing too much and overworking? This kind of goes a little bit with what we were saying earlier, Ollie, around cross-functional members of the team, doesn't it? I mean, from a DevOps perspective, you want people that are going to be thinking about those things and are getting involved in those things. But there will be a time where people will just need to knuckle down with their area of expertise. And that's absolutely fine. That happens in every project. I think that just having the ability to actually be able to do those things rather than just your specialist role every single time is where the value is here. So if you are, I mean, it's going to sound a bit weird saying this, but it is just the simple T-shaping of an engineer, isn't it? That one person may be fantastic in UI, but dabbles in the test side of things, and also can get involved in the platform side of things. As long as they are measuring platform test automation and UI code as part of their story points and their analysis as they go through a delivery, then there should be no reason why people are getting overworked, because they should be accounting for that work as part of their delivery. Have you possibly, Colin, Elliot, have you got any thoughts on that?
I would probably build on that last part you said there, Josh. I quite like my teams to always be cross-functional, to be able to pick up different elements and explore different areas so they can enjoy those new challenges, as I would put it. They have the opportunity to dabble in the different areas they may be less familiar with. And some people really enjoy that process. Others like to just embed down the skills that they are more mature in, and that's good too. But either way, we should be factoring that into estimates and the daily delivery that we are trying to achieve each sprint, each iteration, etc., to make sure that people aren't doing too much and we're not expecting too much of people. It just depends where their time is being spent, whether that's on their core interest or on something that we're trying to develop them more in, or they want to develop more in as well.
Yeah, have you got anything to touch that, Ollie, as well?
I guess it's just, making clear, it is what you said really, it's recognising that work. You want teams to be enabled to handle the problems that come their way, and you want the team members to be able to unblock themselves if there are test or platform issues for a developer, for example. But if people are being stretched too thin, something's probably gone wrong somewhere else. I don't think that's necessarily an issue of cross-functional teams themselves.
And I'm just going to draw attention to the wonderful fact that we have an Ollie, an Elio, and an Elliot, which means that I don't know whether Josh was actually directing the question at all three of us. So, Elio, do you have anything to add to this?
Yeah, I'd say let's say in terms of atomic design experience, when I came across the first time was like a couple of years ago. And I remember that was really nice to have this idea of atom, molecules, and organisms and templates. And the way that myself and my team started work as designers, we started working from designing the atoms and then the molecules and organisms. But then we realized when we start putting together all those components to build actually a page, a template, it looked like completely different. Like it seems that the UI it was designed by 100 designers from different backgrounds, different styles. It was completely horrible. So one of the things that lessons learned was that from the design point of view, what we do is we design the whole UI first. Let's say if you're booking a flight, you're going to design the whole booking flight feature. And then from there, once we know that, okay, this has a really good user experience, and then we start breaking down in organisms, molecules, and atoms. That's the way that we do in design. That's the lessons learned from design.
And yeah, for completeness, I'll add my 2p in and around, you know, effectively the overworking of you know, getting all these cross-functional people to do too many things. For me, it just, you know, I'm going to sound like a broken record here. It just comes back to those interactions between the team members, really. If I'm working with Colin and he's fulfilling a business analysis role, if Colin goes on holiday for 3 weeks, I kind of don't imagine that we need to drop another business analyst in to help out with that. I hope it might not be done anywhere near to Colin's standard, but I'd hope that we would be able to, you know, do stuff well together as a team. So that helps that, but also I'd hope that those interactions would not prevent us actually raising to delivery management that, you know, overworking and you know, all these processes being a burden. If it gets to that point, I would hope that, you know, a really good, well-gelled team would actually raise that and say, well, we need to stop. It's not okay to just keep on adding more. Your velocity is not just going to keep on accelerating. It's going to stop at some point, and it flexes. And you know, that's just one of many things that, unfortunately, you can't just add more people in and it go quicker. It doesn't always work like that.
Yeah, great. I think the most important thing there is that whatever you did for Colin, he would come back and fix it for you. So.
Yeah,
excellent. We've got a fantastic. The next question is also fantastic as well. We've got the one from Harry Preston here, which is: have you used atomic design principles in any project without a UI focus? For example, data processing or analytics, and if so, how did it go?
Yeah, I agree. It's a fantastic question. From my perspective, atomic design is obviously just a pattern that's been applied to the UI, but you're absolutely right that it could be applied to other things. I think as I said, you know, throughout some of this, it's been that accelerator, and I don't want to oversimplify it, but for me, it is effectively good, some good rules around object orientation. So difficult to answer, because I think if you do OO correctly, if the phrase I've used before is taking the page object to its natural endpoint, whereby you go to the lowest level. I think if you do that already and you follow some engineering principles and good object-oriented design and DDD, I think stuff would work quite well, and you wouldn't necessarily even have to call it atomic design. But again, I think it's down to the industry that we end up with these, you know, this artifact that's quite big, that's complex, and sometimes applying a human concept to that helps us understand that a bit better. But if we weren't to call it atomic design and just or lower level page object, it would be the same principle. So yeah, atomic design, I wouldn't call it that. I'd just call it OO in any of those other domains. But you draw a good point that maybe they need something equivalent for a pattern that's repeated across the data space or perhaps analytics.
Just thinking about it, I personally haven't worked on a project where you could apply it to analytics, but thinking about it just now, I think it falls quite naturally when you look at that top level requirement of how we're trying to record and understand certain elements and then report on these to sort of measure success. However we want to define that success, that can quite easily break down into how you're into smaller elements of where you are measuring things and those interactions right across the page, right down to very low levels of cursor movement to clicks to events, the different scripts you may have in the background, to then scale back up to overall what is the company trying to achieve by getting these sorts of analytics. So I absolutely think that could apply very well to the atomic design as you guys have laid it out throughout this presentation.
Yeah, I think just something on top of that is, I guess some of the processes and things that we're striving for within atomic design could be, lifted and shifted into other areas, like you've said. So that there could very well be a place for an atomic breakdown style process in the world of data analytics. And yeah, the general sort of agile principles that we're trying to reinforce with this life cycle, there could very well be an analogy in a data project.
I was just going to add to that. This is going to sound a bit weird me saying this, but a lot of this also comes down to a little bit of the microservice architecture, where the way that you set up your applications, your systems, really does rely on how the communications in the business work. So for this perspective, you need to have solid teams that all know how to communicate internally as well as externally. And I think if it's worth, going down this route, one, you do need to analyze and assess what your current team setup looks like, but also what the interfaces are between your team and external teams. I don't see any more questions in the Q&A session, but there is just 2 more questions that I would like to propose to the group. So first one is, are there any disadvantages to atomic design? I guess Elliot or Ollie first, and then we'll probably go look at it from a business and a design perspective after, if that's okay. So Elliot, fire away.
I was just going to say no disadvantages. No, I think it's something that we covered throughout this, which is something we're going to be really careful of when we use it, which is, the biggest disadvantage for me is that it becomes more about the event and the process as part of our development life cycle, rather than the interaction that it's trying to cause. It is a pattern. It doesn't have to be used everywhere. It's I think it's Luke that told me, give someone a hammer and they think everything's a nail. And yeah, it certainly, I don't want to ever see it used like that. So that is a disadvantage, that those self-siloers that Ollie talked about, it's probably a very similar attitude sometimes that would just say, oh, but we're doing the atomic design breakdown, so we can't be doing anything wrong. And yeah, we need, it's all about the interactions and the collaboration, not at all about the any outcomes or deliverables. That's just an added bonus for me.
It's probably worth saying as well, part of this sort of ties back to Luke's initial question about that abstraction. I think part of the pain that Luke may have felt there is when we were doing this initially, and it also handily ties into the question Dan has just put on, but we were applying these practices from a test perspective to an application that wasn't designed with atomic design in mind, and retrofitting it. We still got the benefits of, applying good object-oriented principles to our test code, but there were definitely, some square peg round hole moments where it was a little clunky because things hadn't been considered from the start. They're only being considered in this way from test. So it's just what we're saying, I guess, throughout the life cycle. If you want to get them the most benefit, then it needs to be considered throughout.
Yeah, I'm going to add just quickly onto that there was a situation where that did happen, that kind of trying to think about an existing system. So what we had, what Elliot spoke about in the history, we had a UI system that was built with an atomic idea in mind, and not always purist by any means or any stretch of the word, but definitely an approach that was taken. Whereas the UI, the automation code, was completely not written like that. There was lots and lots of repetition, duplication throughout it, because it was a simple way of working on it. Now, I am all for going against trying to retrofit something into an existing system and a way of working, but I think with this atomic approach, you could actually do it in an iterative fashion. So you could just target the small low-hanging fruit areas, get them out of the way, and then consider, the larger changes over time. So effort-wise, it will take time and effort. 100% will take time and effort, but it's something that there will be value there because you'll get a better understanding of all the different parts of the system long term. Could I just swing by Helia and Colin then? So have you guys noticed anything from a disadvantage from atomic design?
No, I don't see any disadvantage as well. As I said, I see lots of advantage from design perspective. The main disadvantage, in my view, is not the main. Like it's more a lessons learned. If you start thinking only in the atomic design components and not the problem that you want to solve in that specific feature, right? On that specific epic. That's the main thing that people sometimes they get distracted to create into the atomic design, the whole design system, and not solving the actual problem. That's the main thing.
Yeah, that was similar to what I was going to say. Again, getting distracted by the methodology or the thing that we're going to use rather than the problem that we're trying to solve. And it is a technique in the end of the day.
Yeah.
But just be careful that it is just that. We can flex on it, how we're using it. Don't get distracted by the shiny thing there that we just introduced. Let's solve the user's problem, because that's what we're trying to do.
Yeah, just to align to that, Colin, one thing that I recommend as well, during the design stage, we always involved the developers during the design stage when they design the components, because we can check the feasibility of those ideas quickly, quicker, rather than delivering something that is not possible to develop. So we need to involve, and communication is a key thing in this process.
Yeah, absolutely. If you don't involve the right parties at the right times, you're just going to cause more issues. So
yeah,
across the team all the time when you're doing this sort of thing. It goes back to the point that I suppose I think it was Josh was saying earlier in the presentation, when you first introduced it in one of your clients, and your planning sessions were becoming quite long because it took a long time to talk about this. But the sorts of things that are necessary, so you can have that open discussion and chat with everyone, and everyone relevant can input onto it at the same time, so you can reap the advantages properly, rather than just, let's cram this into an hour and a half or half an hour, and you skip out all the half of the people that need to be there. Then you fall into traps.
Yeah, from that experience, I know that when we did cram it into, say, half a day, we ended up with far more issues and broke out of those sprints. And whether it's anecdotal or not, when we started taking a full day over the planning, you might think, oh my goodness, a full day to do all that planning. But suddenly we actually started delivering what we expected to, because we'd done that proper breakdown. And again, it's just jotting that feedback loop rather than figuring out something's going to be a problem on day one after you've committed to a sprint. You figure it out on day zero before you've committed to it.
Yeah, I think that is a scary thing, isn't it? That planning could take a whole day. I'm not suggesting that we would ever need to get back to that level again. It could happen. We don't know. It depends on the team. But just the values that we got out of that, the implicit knowledge. And although you are spending a day planning and you're not just churning code out, there is obviously, you are working towards the end goal of that sprint, which is to have, one, a better understanding of what you're delivering, but two, delivering that thing in high quality fashion as well. So it gives you a little bit more than just losing a day as part of your metrics for each sprint iteration. I am going to looking at QA section here, we've got another one by Luke now. Luke said, I think I used the hammer analogy about BDD and gherkin. It's right in that space. It's always a massive risk when you've got a shiny tool / process / methodology that you should just be chucking it, that you just start chucking it at everything. Sorry, I butchered that towards the end.
I think, I'm not sure, Luke, feel free to correct us, but I think it's not actually a question. That is just, it's his only method of communicating.
Yeah.
So the fact that I was talking about it in a very similar vein, hopefully is, exactly what Luke had said to me previously about that hammer analogy.
Yeah.
That does lead us on to a point though. Did we want to talk a little bit more about the relationship with Gherkin and atomic design going forward, Elliot?
Specifically, are you talking about my wonderful picture?
We can talk about the picture and then we can talk about maybe how this could actually be the next BDD.
Yeah, no. in case it wasn't obvious, on stock image sites, it is not very easy to find ATOHIC spelled out of a cucumber. So one was sacrificed for the making of this presentation. Yeah, no, I honestly think that, if you had a marketing company behind ATOHIC design, I'm sure that they would go off and make it something that it maybe is and maybe isn't. Yeah, maybe it could be the new BDD, but I don't know. Right now, where it feels like is yeah, that might be a good thing. That might not be a good thing. I'd like to see how the industry treat it. I'd like to put it in front of more people. I'd like to figure out more of the nuances and the things and keep on iterating on it. But I'd also like to hear stories of other teams that have done something similar. As I've said before, we're not the only team that have used ATOHIC design. I know that there's definitely other companies in Sheffield that use ATOHIC design, but they are not using it for specifically any testing code. And again, it'd be nice to just see something happening out of this that starts those discussions. So yeah, maybe it could be the next BDD, but again, I don't want it to be a fashion or square peg round hole. I think if it becomes a thing, it'd be nice to see that. It'd be exciting to see that, but certainly don't want to force it. Want it to go there naturally. If it has the legs to do it, then that'd be nice. If it doesn't, yeah, you keep on iterating until maybe it's something new. I don't know if that answered what you were thinking on the BDD gherkin.
I just wanted to know about the cucumber, that was all.
That was all, yeah.
Long explanation, but thanks. Right, okay. I think what we'll do is we'll wrap it up there unless there's anything anyone else would like to add. No, excellent. I will say thank you to Elio and Colin for joining us. And thank you to Fern for setting this up as well. And I think we will wish you all a good evening. Thank you for coming.
Cheers, everyone.
Thanks, guys.
Thank you.
Thank you. Bye.